Bismillahirrahmanirrahim. Assalamu alaikum, dear student. Mm, In lecture 6, basically, we didn't complete the topic of book, which was incomplete. So, in this lecture 7, inshallah, I will try my best to complete that topic within one or two examples. Okay. In that lecture, we will uh, discuss these kind of factors. Okay. Uh, and uh, these kind of factors is, it is a little bit confusing factors, and although there are some factors are clear, but the this stereo factor, which is called confining factor, it is a little bit tricky and it is a little bit complicated. Okay, so we go to the Nilson book, and we search out these factors there, because in Nilson book it is a little bit simple and a little bit easy and understandable. Okay, this is the formula which Nilson book presented. This is the same formula as given in McGregor and Cormick book, but they don't use this 50. They written it as a. If I show you that formula, so basically what they did, they used this formula in this pattern. They place 0.02 here, and the rest is same. The rest formula is same. Okay, that is lambda and FC prime. Both give you the same answer. Okay, both give you the same answer. But they also they only use one factor, that is psi e factor. Okay, and then after calculating the length LDH, then at the last stage they multiplied those psi c factor. Okay, the last stage they multiply psi c factor and they multiply psi r factor. Okay, so Nilson make this formula a little bit simple. Okay, and it is, little bit easy. Okay, so here you can see this sine e factor. Okay, that is coated factor. Okay, epoxy coated factor. If there is epoxy coated or zinc or epoxy dual coated reinforcement is used, so you have to take this one too. And uncoated or zinc coated, just only zinc coated, so you will use one. This coated factor is clear and simple. It is not complicated, but this factor is a little bit complicated. You must know about this factor. Okay, you must understand this factor. Okay, clearly. Okay, okay. So this size C factor is called the cover factor. Okay, and as at the beginning of lecture 6, I clarify some three factors. Okay, the one is side cover. Okay, the other is top cover. Okay, and the other is tail cover. I completely define these terminology. Okay, what is side cover, what is top cover, and what is bottom cover. Okay, the side cover is basically measured from the side of the beam to the face of the stirrups or to the face of the bar. Okay, it may be up to center. Okay, maybe counted up to center. Okay, and bottom cover is, measured from the center to the this face, or from the face. It may be clear spacing, or it may be center to center spacing as well. And tail cover is basically that cover which is after the we provide after the bend. Okay, this is bend portion. So this from this outside face of the hook to the outside edge of the beam. Okay, so this is basically tail factor. Now Here it says that for number 11 and smaller hooks with side cover, okay, which is if side cover is greater than or it is equal to 2.5 inches, you know, 2.5 inches, and your tail cover, that is extension cover, also it is greater than or equal to 2 inches, your sin C will be 0.7. Clear? This is clear. Your top cover will be anywhere. It may be any value. It may be greater than 2.5, it may be less than 2.5, but these two covers must be greater than 2.5. Then you have to select 2.5. Okay. But if these both covers criteria not fulfilled, if one of them becomes less than 2.5, then you have to select one. You will see this is an example. You will select this one. Okay, this is clear. This is, you know, this is a beam, and this is the support. Okay, and you see that this beam is continuous to this support, but this is the free end of this cantilever beam. So, free end of cantilever beam, there is a little bit differences between continuous and discontinuous. This is discontinuous edge. This is also discontinuous edge, and sometimes a discontinuous edge when a beam entered or framed into a column. This is also, and when simply supported beam occurred, so this is also discontinuous edge. So one is continuous edge and one is discontinuous edge. So you must know the difference between these two because it is comes under use. Okay, so if you provide support here, okay, if you provide support here, okay, so this is discontinued edge, this is discontinued edge, and these two are continuous edges, continuous. Okay, so with discontinued edges, what we did basically, we provide these kind of stirrups. Okay, these kind of stirrups. So what are the criteria for these stirrups? This is called basically confinement, and these stirrups are provided to the whole development length of the hook. Okay, and remember their spacing should be less than the first stirrups should be placed from the outer face of the hook to the center will be placed at a distance of should be less than or equal to 2 dB, and then center to center distance will be less than or equal to 3 dB. And one thing must be remembered, sometimes such examples are given that showing you this kind of arrangement, which showing you this kind of arrangement, and spacing is given. Okay, spacing of these stirrups is given. You just and you have to select your psi r factor, because the psi r factor is called confining factor, which deals with this arrangement. This arrangement may be this kind of arrangement is called perpendicular, because here stirrups are perpendicular to the bar. Sometimes these stirrups are placed parallel, which is called parallel arrangement of ties. In such case, like if the hook is provided like this support, the hook is provided this support, so this tail extension basically we provided and the beam is cut over here. So we must provide, because in the column basically we provide longitudinal bars as well, and we provide ties. So those ties are designed perpendicular to this extension. Okay, this extension. So this is called parallel arrangement. Means these stirrups are basically perpendicular to this extension while parallel to the bar. Okay. So this is, and their distances will also meet the same criteria as mentioned here. Okay. They are placed at the same criteria. Okay. So sometimes this is parallel arrangement and this is perpendicular arrangement. Okay. So you will see this when we discussing those ACI criteria. So you will see perpendicular arrangement, stirrups and parallel arrangement. So this is parallel and this is perpendicular. Remember that sometime if sometime in examples the joints are given to us and they say select the psi r factor and the stirrup spacing are given. So if the stirrup spacing are given, you just calculate this 3 dB, okay, and if that spacing is if it is less than 3 dB, okay, if it is less than 3 dB, so you will search out the psi r factor from table, okay, what code says. But if it is greater than 3 dB, then your psi factor will be 1. You will see this is an example, okay, in a Mcgregor book. So if this spacing which is given you, if it is greater than 3 dB, so your psi factor will be 1, okay. So this is a little bit explanation of this, okay. Now we discuss this psi r factor. What is psi r factor? It is a little bit confusing term. So let's see what this is. The this is the psi r factor. This is called confining factor. 190-degree hook, okay, with number 11 bar and smaller bar enclosed along LD edge within ties or stirrup perpendicular stirrup through its LD edge and spacing should be less than 3 dB. R enclosed along the bar extension beyond hook including the bend within ties or stirrups perpendicular to the tail extension. This is it. Look, stirrups are placed perpendicular to tail extension, means parallel extension of the hook and specified same criteria. Okay, then your spacing, then your psi r value will be 0.8. If it fulfill that criteria, in 90-degree hook, then your psi r factor will be, for example, if it spacing is like in this case, if it spacing is less than 3 dB, then your psi r factor will be 0.8. Okay, your psi r factor will be 0.8. Okay. And if it is greater than 3 dB, then so this occur when spacing is given, but sometimes we design it, okay. If it is not given, then we design it. If it is given, so we check it. That's what it will be the psi factor. Okay. For 180-degree, the same principle apply, but for other cases means when these criteria are not met, means the spacing is greater than 3 dB, so you have to select one. That is obvious, clear. Okay. Your lambda factor, that is 0.75 for lightweight concrete and for other type of concrete is 1. It should be remembered, you have to multiply the steel ratio as well with that formula also. Remember, as you will see in the previous that whenever we are calculating LDH, so you write the rest of formula, you multiply the factors psi C factor, psi R factor, as well as psi C, psi R, psi E with A is required divided by A is provided. You must multiply this factor, but there are some restrictions. Okay, if you are designing in seismic zone, do not multiply this term. If you are designing the ends or you are designing the joints at are determining the development lengths of hook at discontinuous edge, like simply supported beams, like the edges of cantilever beams, planes, and something like that, or will like this case when the beam ends in a column and that doesn't proceed or pass to that point and they stop there. So in this case, you not need to multiply this factor. Okay, this factor will not be multiplied. Okay, so this criteria must be clear. They are mentioned there. Okay. This paragraph is very important, and most of the time it creates a kind of confusion. Okay, According to ACI code 25.4.3, for bars hooked at the discontinuous ends of members, discontinuous ends. I define you discontinuous ends. Simply supported, can deliver and something like that. A member with both side cover and top cover. Both side as well as bottom when they are less than 2.5 inch hooks. Okay, must be enclosed with closed stirrups or ties. Now, it should be remembered in this case, whatever the value of your tail cover, your side cover, okay, if it is less than or equal to less than 2.5, okay, if it is equal to, yes, if it is your top cover or bottom cover less than or equal to 2.5, okay, and whatever the value of your tail cover or extension cover, whatever their value, any value, you have to use what what you will do, okay, you have to provide stirrups, confinement stirrups, okay, must not exceed 3 times the diameter of the hook bar BB, and the first stirrup should be placed at a distance of 2 dB, and in this case you don't need to multiply psi r equals to 0.9. That this is the special case, okay, this should be the special case, and you must note this, okay, from this table which is given in the Mgregor book, that whenever your side cover is less than 2.5, your top or bottom cover less than 2.5, and your tail cover whatever they will be, you need to provide stirrups at those criteria, and you have to take psi r is equal to 1. It only occurs at discontinuous edges. Okay, your psi r will be 1. Okay, this should be clear. Okay, this is a very important table. Okay, this 1 to 5 criteria are, you can say, these uh, rules or criteria will be used for continuous edges, while this one is for discontinuous edges. So you can select your psi r value. This is psi r value given for psi r value. This is for psi r value. Okay, this gives you psi r value. So if your side cover greater than 2.5 and 180-degree hook less than 11, your top cover and tail cover value will be whatever their value. You no need of stirrups. It only at continuous edges. Okay, this factor will be 0.7, and for 90-degree hook it is also applicable. Similarly, this one is also applicable, but your side cover should be greater than, your tail cover should also be greater than. Okay, both are greater than your top cover, which anyone. Okay, you have to multiply 0.7, and similarly these are applied for from 5 to 1. This is for continuous edges, and this is for discontinuous edges. Okay. Uh, let's see. We will do an example which is from Nilson book. Okay. The example is that referring to the beam column joint shown in figure 6.8. So there is a figure 6.8. This one. So you must know about this example. This is a quite simple example. Okay. This is a beam column joint, and the beam is discontinued, not continued. Okay. You see the side cover, which is from the face of the bar to the outside. That is side cover is 1.15. Okay, and you see that number 3 stirrups. Okay, this is number 3 stirrups, and these stirrups, the initial stirrups, these 3 are placed at a rate of 3 inches center to center, and the rest are will be placed at 5 inches center to center. Okay, I will explain this whole diagram in example number 1. Okay, but The question, the most important part is this one. Okay, the most important part is this one. Okay, and you see that the beam, the column is continuous in upward direction as well as in downward direction. So top cover and bottom cover, there is no restriction. There is that are clear that top or bottom cover is the more than 2.5 inch because there is no discontinuity. Okay, they are continuous. Okay, but the side, the tail cover which is given, that is 2 inches. Okay, so tail cover is also equals to 2 inches. So this is our design criteria. Okay, this is a very important okay for us. And side cover 1.5. Okay, so side cover is less than 2.5 inch in my view, and you see that you need to calculate this development length. Okay, this length, the bar is extended, and then they are hooked. Okay, so this is, you know, this LDH, how much we kept it. Okay, so this is I think so the requirement in this question. Okay. Referring to beam column joint shown in the figure, negative bars are to be extended into the column, yes, and terminated in a standard 90-degree hook, keeping 2 inch clear to the outside face of the column. That is the tail cover. Okay, and the column width and the direction of the beam width is 16 inches. Find the minimum length of embedment of the hook past the column face and specify. This 16 inches means that the column, which is the beam which is exerted, you know, which is inserted into this column, you know, you see it, this. So the beam, if you draw the plane view of this beam column joint, you will see something like this, you know. This is 16 inch, and you know, this is 21 inches. Okay, so this side is 21 inches and this side is 16 inch, I think. Okay, this is 16 inch, but as the beam uh, width is 10 inches. This is interesting. Okay, there is offset. This is not flush. This is not flush with the column. Okay, this is not flush. Okay. So there is some distance. Okay, there is some distance. So the bars, you know, there are two number 11 bars, negative bars. They are extended from the beam to the column. Okay, this one and this one, they're extended. You know, now we need to calculate this distance. You know, we need to calculate this distance. Okay, that how much this distance will be. This is the side cover. Basically, this is the side cover. Okay, this is the side cover. Clear? This is the side cover. So we will calculate this side cover. Okay, let's see. The column width, the column width and the direction of the beam width is 16 inch. Find the minimum length of embedment of the hook past the column face and specify. So calculate LDH. The development length for hook bar measured from the critical section along the bar to the far side of the vertical hook is given by equation this. I will already write this equation. Now you have to select epoxy coating factor. Okay, so epoxy coating factor, as there is nothing to say about coating, so your E will be 1. You can take it 1. Okay, as well as what will be your psi C factor. Okay, what will be your psi C factor. Okay, and what will be your psi E factor. Clear? So you need to calculate your side cover right now. Okay, because you will decide on your side cover. So there is 1.5 inch side cover. So, and this is 16 inch, so 16, basically this is 10 inch. This distance is this side width of the beam is 10 inches. So if I extend it, okay, so 16 minus 10 gives you 6 inches. So 3 inches will be this side and 3 inches will be this side. I think so. Okay. So 3 inches plus 3 inches, 6 inches means this 3 inches plus this cover 1.5 gives you the total side cover. Okay, gives you the total side cover. Let's see. The side cover for the number 11 bar exceeds 2.5 inch because it is calculated in example. I think it is not measured, see here, but in example you can calculate it. Like side cover, how we calculate it? Side cover will be 3 inches plus 1.5 inches. So this will be 4.5 inches. Now 4.5 inches is greater than 2.5 inches as well. And for size C factor, as your tail cover, if you look to your tail cover is also equals to 2 inches. So this fulfill the criteria, as we mentioned. It fulfill the criteria as we mentioned, like there, that says number 11 bar is the case because the bar size is number 11. Number 11 are smaller. Okay, so the side cover is more than 2.5 inch, that is fulfilled, and the tail cover or extension cover which is given to us, that is equal to 2 inches. So it is equal to 2 inches. So our size C is equal to 0.7. Okay, if it is less than 2, then we take 1. Okay, so that is quite simple. Okay, our size C factor is equal to 0.7. Yeah. Now we have to select our psi R factor. Okay, psi R factor. We have to select psi R factor. Yeah. Now psi R factor, as it is a discontinued edge, it must be remember the beam is discontinued here. Okay, so that is definitely, and as you will see that side cover is increasing from 2.5 inch, not less than the discontinued edge. That is quite simple, that it will be 1. Okay, because it is discontinued edge. So the cover factor is 0. And the confining reinforcement is such that psi r is equal to 1. This gives you, because this is discontinued edge and also not fulfilling the criteria, because in case of discontinued edge you will take an at 1. Okay. But if it is a continuous edge, you will check out side cover and top cover and tail cover, and then you will consider. Okay, so just putting the values. Okay, your psi E, psi C, psi R, and dividing by this term. Okay, lambda is equal to 1 because light weight component. Okay, and you will get 19 inches. So, okay, the only other factor applicable, yes, you can multiply axis factor, axis reinforcement factor, axis reinforcement factor, which is 0.93. Okay, as an example, accordingly the minimum development length will be 18 inches. Okay, so as you will see here that this factor, as for straight reinforcement in tension, permits the development length of a hook LH to be reduced by the ratio of this, except where increase or development for FY is specifically required or in specific seismic zones. You don't multiply them that factor. Although it is not multiplied by uh, discontinued edges. Some book also specify it, but here they multiplied it. Okay, it it reduces the development length by 1 inches. Okay. Now how much distance is available to you? Okay. You should need to calculate that distance. As you know, from the face of the column, from the critical section to the to the bend portion, if I try it, okay, if my this is my critical section and this is my beam, okay, this is my beam. The bar should be entered or entered into this column for a length of 18 inch or 19 inch, okay, and then you provide a hook. Okay, so how much distance? Look, this distance is 21 inches. Okay. This distance is 21 inches, and there is 2-inch gap. Okay, that is stand cover. So the distance which is available to you is around about 21 minus 2, that is 19 inches. So the development length of the hook can be easily adjusted. Okay. Now this is after this 18 inches. Okay, you have available space is 19 inch. Okay, so you you can provide your you can easily provide your hook. Okay, because if it is not placed here, then you will reduce the bar size. Okay, then you will reduce the bar size and then check it. Okay, so here the development length of the bar, so there is no problem. Okay, and the other thing is that it is very important. Okay, that you have to provide a bend. Okay, you have to provide a bend, and the minimum diameter of this bend, for number 11 bar, it is, if you see the specification of standard 190 degree bar, it is equal to 8 dB. So this diameter of this bend will be 8 multiplied by 1 point some roundabout, whatever the diameter of the bar, and then after you have to continue it for a distance of 12 dB. Okay. So this will give you total, and this this will be the hook development length. You can say this is the LDH, which is measured from the critical section of the member. Okay, and this is the extension length. This is the tail length. Okay, this is the bend, and this is the lead length. Okay, development length. Okay, so this example, 8 multiplied by dB, that is 1.41 is the diameter of number 11 bar, gives you at 11.28 inch is the diameter of the bend, and the bar will continue for 12 dB. This means 12 dB. So multiply 12 multiplied by the diameter of 1.41 gives you 17 inches. So 17 inch will be the length of the this length should be 17 inch, and this uh, diameter which will provide this bend will be equals to 8 dB, and this length will be 18 inch. This length will be 18 inch. This is the design of board, which is done in the you know which is done in the Nilson. Okay, so if we come uh, to McGregor book, there is also one example. Okay, and is also related with the hook design. Okay, so that example is where yes, this one, no, not this one, this one. Okay, this is the example which is given. Okay, this is a quite simple example. the the whole diagram is given. Okay, the whole diagram is given by snap it. Okay, so this is the diagram. Okay, you need, whenever you are solving the hook example, you need both section view as well as plane view, because from plane view you can count your side cover, while from section view you will count uh, your tail cover, okay, and your top and bottom cover. So this is the example. You see that there are four number 8 bars which are negative bars, and this is also a discontinued edge, okay, discontinued edge, because the beam is framed into a column, okay. So basically you see that the dimension of the, which is given, the dimension of the column is given, that is 24 inches, okay, 24 inches. So this is 24 inches and this is also 24 inches. This is a square column, you know, this is 24 inches, okay. This is 24 by 24 inch square column, okay, and you will see that the column, the beam is 16 inch, so there is offset, okay. This offset will be how much? Both side, okay. 16 minus 24, that is around about 4 inches, okay. And you must know about that the spacing, clear spacing from the stirrup face to this face, it is 1.5 inch. It is given, okay. It is given. This stirrup is basically given that this is number 3, so its dia will be 3 by 8, and this is 0. Around about 0.38. Okay. So what will be the side cover? The side cover will be measured from the face of this steel to the face of this column. Okay. So this cover will be, this means that the side cover will be 4 plus 1.5 plus 0.3, okay, which is, I think so, 5.5, and comes out to be more than, you know, more than 2.5. So side cover is, comes out to be more than 2.5, okay. Top cover is not a problem because the column is continued both sides, so there is no restriction. Top cover is almost greater than 2.5. But the question is that the tail cover is a problem for us. Why? Because we see that the distance up to this face of this, the distance up to the face of this stirrup is 1.5 inch and 0.38. So this will comes out to be 1.87. You know, this is not given. You must calculate it. But uh, this from the face of the stirrup, so this is the side cover, okay, this is the tail cover, sorry, this is the tail cover or extension cover, which is counted from the face of the hook to the edge, and this is equal to 1.5 plus 0.38 or number 3 bar, okay, number 3, and it comes out to be 1.87, which is, now this is a problem for us. Okay. Side cover is greater than 2.5, but tail cover is less than 2.5. This is problem. So if we want to select the psi c factor, uh, so when this one and this one greater than 2.5, so your psi c factor will be 0.7. But as between these two, anyone less than 2.5, the psi c factor will be 1. That is clear from Nilson. Okay, that is clear from Nilson. From this, okay, I explain it. Okay. Now psi c is clear. Psi e basically is 1 because there is nothing saying about the coating. Okay, and lambda will also be equals to 1. I think so. That is also 1 because this is I think so. normal vertical grid. Okay, so this is also 1. Now the question is about psi r. This is the confusion one. Okay, now what value we will take? Okay, if we look to this diagram, this plan view, it, it you know it representing uh, you know it representing this this value is a tricky one. Okay, it says that there are two number of ties, three ties, two number three ties, means number 3 diameter at the rate of 5.5 inches. So the ties which you are seeing here, this one, okay, and this one, these two ties are placed at a rate of 5.5 inch, from this 5.5, from this 5.5. So now stirrups are given. We check this spacing, whether it is greater than 5.5, greater than or equal to 3 dB or not. Okay, if it is greater than, then your psi r factor will 0.8. Okay, 0.8. But if it is less than, sorry, if it is greater than, so as it doesn't fulfill the criteria, so it will be 1. Okay, your psi r factor will be 1, and if it psi r factor is less than, sorry, psi r factor, if your 3 dB, your 3 dB, if your 3 dB is less than 5.5, then psi r will be, then your psi r will be what? Will be 0.8. But it should be remembered that this is discontinued edge. Your psi r factor will obviously you will be considered at 1. Okay, you will be considered at 1 because it is discontinued edge. Now if we check it that whether it is greater than or less than, so you can determine it. Okay, as you know, the the the, the diameter of the tie is number 3, so you can find out the AV, that's area will be comes out to 0.22, okay, which is 2 multiplied by 0.4411, sorry, that is the cross sectional area of one leg of the tie. Okay, so it will be 0.2. So if you check it from shear criteria, so you can use those 4 criteria which I will mention in lecture 6 and lecture 5. So from there you can get the value S. You know about S. Okay, S will be AV Fy divided by 50 into BW. Okay, so you calculate your S. S can also be checked out from 0.75. Okay, sorry, you can check it from AV Fy divided by 0.75 BW into HC prime. Okay, you also check it from D by 2, so you will get the minimum one. Okay, you will get the minimum one, so that will be your desired S. If you calculate it from there, when they is calculated, so they get 11 inches. Okay, in the book when they calculated it, they get 11 inches. Clear? This one they get 11 inches. So this is, this is S. So as this is basically S, 11 inches, and 11 inches. Okay, so your side cover is 5.875. I will calculate it, and this exceeds 2.1. So your size C factor will be what they will be. This is your tail cover. Okay, and your size C factor will be 1, clear, and uh, your 3 dB is 3 inches. So it is right now clear. Okay, your diameter of the bar is your diameter of the bar is uh, mm, number 8. So your bar diameter is number 8. This is your design bars. Okay, so that is number 8. So your 3 dB equals to 3 inches. Okay, your 3 dB will be because you are using number 8 bar. So number 8 bar diameter is 1 inch. So your 3 dB will be mm, your 3 dB will be equals to shit, my computer is loaded with comments, so it's creating a kind of problems. Uh, my 3 dB. So your diameter of the bar is 1 inch because that is number 8. So it comes out to be 3 inch. So 3 inch is less than 5.5. So 3 inch is less than 5.5 inch. So your psi R factor is 1. Okay. Your psi R factor is 1. So here they are given. Some cases we calculate it. We calculate it. Here that is given. Sometimes you need to design it. Okay. But there they are given. So from given you will determine your psi R factor. So just multiply those psi R factor and where this one. Okay, not this one, this one. Okay, so you get the length of your LDH. Okay, which was this one, 19. So multiply 19 with, you multiplied it with psi E factor, just multiply it with the psi C and psi E. Psi C is also 1 and psi R is also 1. So 19 inch remain is 19 inch, and the length which you have available for placing of the bar is, this is 24 inches. So 24 inches minus 1.87. Okay, it give you the cover which is available. Okay, from this space to this space. This space will be 24 minus 1.87. Okay, it will comes out to be, 22.1 inches. Okay, so 22.1 inches, 22.1 inches is more than 19 inches. So your bar can be easily adjusted. Okay, and you will also you will provide 90-degree hook. So just determine the minimum diameter. Okay, and determine the straight portion as well as the hook length which is calculated, LDH is calculated, that is 19 inches, and you will calculate your minimum diameter of bar for what number at bar, what is their value. Okay, that is 4 dB and 12 dB. So for 11 diameter bar, number 11, that is 8 dB, but for number 8 it is 4 dB. Okay, and 12 dB is the straight portion. Okay, so just calculate the straight portion. Okay, and the diameter of the bar will be 4 dB. Okay, so it will give you your bend dia as well as your straight portion or the tail portion, tail extension. This tail extension, this and there is bend. Okay, so there is a kind of circle, there is a kind of circle, and whose dia will be 4 dB. Okay, and the straight portion will be 12 dB. Okay, and the this lead distance will be 19 inches. This is your required, this is your required design of hook. Okay, so this is all about the the end of the end of your your hook design. Okay, so it is, I think it is most simple, but if you understand the factor like psi r factor, the only factor is psi r factor, that is a little bit confusing one, and if you understand them, it is a quite simple and most interesting topic. It will help you remember in so many areas. Okay, it will help you because most of the time people get these values from appendixes, from ACI graphs and appendixes, but they are for certain loading, they are used for certain types of loading. Whenever the loading is unsymmetrical load, you have unsymmetrical load, then you will need to calculate these distances. So these development lengths and these hooks lengths bond calculation, it is very necessary, for drawing point of view. Okay, you have to provide specific these lengths, and you will see now further whenever I was proceeding this chapter. So when I was calculating the cut-up bars, so you will see the application of these bars, inshallah. And next we will comes to cut-up bars, and that was the whole theme of development length and hook design. Okay, because you will see a kind of fruit of this topic at the coming topic. Okay, in the coming topic you will see that how much development length calculation is important, how we use it for cut-up points. So next topic is very interesting, and you need to completely understand specifically development length topic. Okay, which will be used further. So development length, we will calculate it for basically we will calculate that length for calculating cut-off points. So cut-off points is very important, and you will see that how we use it, and it is very important because most of the time you will see that the negative reinforcement which were used in mm, where is MC called me, this one. So you will see that whenever we are detailing, so most of the time we basically what we did, if I give you a little bit summary of the coming topic, so you will understand it, and you will keep some kind of interest. You see that whenever we are detailing bars, okay, I will also discuss it in my initial lectures. So if this beam is inserted into a column, okay, and this beam is also inserted into a column, okay, there is a column. So you will see that we provide hooks like here, okay, and we also provide hook like here, okay, and we cut some steels in the mid portion after this portion. Okay, now how these bar are cut up, and then we provide you know uh, negative steel reinforcement. So this kind of, if they are, this is called cut off. Okay, this is called cut up because this bar is cut up here and it plays there. Okay, so this is called cut up, and if we cut there and we place that bar after this portion. So this is called cut down. This point is called cut down. This point is called cut down, and this is called cut up. Okay. So these cut up and cut down points, how much this distance will be, how much this distance will be, how much this cut up point will be, how much you will continue this bar up to how much distance, okay, and how much you will insert this steel up to this point, okay. These are interesting topics, okay, which are in coming inshallah in next lecture. We will discuss this thoroughly, uh, and uh, I think you people need to recap your those topics which was covered. So if you have any question, if you have any uh, doubts about these topics, I welcome. And my contact numbers, my all contacts numbers are there on the screen. You can contact